share ಮಾಡಕ್ಕೆ ಹೇಳಿದ ಲಿಂಕ್ ಅವನಿಗೆ. Yes. Students are still joining.
Yeah,
Okay.
let them join.
So hello students, welcome back to our YouTube channel. So now from today we are going to start our fresh course for the 27-28 batch for the ICAR PG exam in the subject of soil science, and these classes are also important for the ICAR PhD and the ASRB net if you are wanting to start from basics. अगर आप basics से start करना चाहते हो, चाहे आप PG के लिए prepare कर रहे हो, PhD के लिए prepare कर रहे हो या ASRB के लिए prepare कर रहे हो, for all of you these classes are very important. But अगर आपका basics सारा cleared है, then you can only concentrate on advanced topic. This is specifically for PhD and ASRB. But अगर आप ICAR PG crack करना चाहोगे, like if you want to crack this ICAR PG in the coming years in 2027 and 2028, so then this is a very important classes for all of you. So now today we are going to start the first class of soil science. So this will be in our YouTube channel. हम इसको YouTube channel में कर रहे हैं और इसके बाद जितने भी classes होंगे it will be in our paid master course. So if you do not know about our master course, like the master course details is completely available in the description box. Description box में सारा details दिया गया है and the validity of these courses will be up to the day of exam. Exam day तक इनका validity रहेगा. And talking about AgriAddict soil science course in the previous years, so we are running this course from last 3 years and we have got the exceptional results in the previous year and this year, as you all know, like we are waiting for the 2026 results and पिछले साल में हमने ऑल इंडिया फर्स्ट रैंकर को प्रोड्यूस किया था and she is also one of the top ranker from the previous batch who is now as a mentor in AgriAddict. She has successfully completed her first year in the AgriAddict and congratulations for that. So now she has overall experience of 1 year as a mentor and 2 to 3 years as a student.
Yeah,
Okay.
right.
So now she is also looking forward to prepare for PhD and she is in IIR in New Delhi right now and no doubt like whatever classes that she is going to handle, so that will be of great help for all of you to understand the core subject of soil science. So along with Purbita, there is also Raunak, Rohit who will be engaging the classes in the different categories or the different topics of the soil sciences. Overall, definitely you will be enjoying all the classes in this entire year. So if you want any feedback, you can directly open our YouTube channel and check the videos that are already uploaded. If you want to see the course, the free demo courses are also available in our platform. So you can just go there and watch it. The links for the demo courses will be available in the description box. So you can directly go through from there. And also like if you have any seniors from your university or the college, so they are the best one to guide you like about the course and the feedback. So just get the feedback from them. Okay, so let's begin. Purbita, I welcome you formally to this new session of 27 and 28. The students are actually preparing from third year, second year.
Right.
So even students who are preparing for 2028, 2029, they are also there.
Tough journey.
Yes. Okay. So this will be a marathon. So be consistent till the end. So if you want to crack it and make your way to IRI or any other top agriculture universities, so these classes will be very important for all of you. So if you have any feedback or any review, you can directly comment on this video. Plus, you can also interact with our mentors on the live chat. Thank you so much. Welcome back again. Please
Thank
engage.
you, sir. So, hello, aspirants of ICAR PG or PhD. So, I welcome you all to our very first class of soil science. And today I'll be basically dealing with the introduction of soil science and why. Why have you chosen soil science as a subject? And we will just read a bit of what soil science is and how you can proceed further. Okay. So, all of you have to be very consistent with me because consistency is the key to success. Okay. So, good evening everybody who are present over here. Why is there no separate batch for soil science net? So, we will be starting that soil science ASRB net very soon batch, and you can get all that link in our AgriAddict app. It is available over there, Jasmine, I guess. Okay. So, let's begin with the introduction and let's hope that you like the class. So, I am Purbita and I did my undergraduation from BCKV and I am currently pursuing MSc in the Division of Soil Science and Agricultural Chemistry at IRI New Delhi, and I had secured AIEEA 2 in the 2025 ICAR PG examination. Okay, yeah, right. So now, okay, so first we will begin with the basic difference between what soil and land is. So you are studying soil science, right? But there are also geologists, right? They are studying about the characteristics of land. So how is a soil different from land? First, we have to know that, because our subject is soil science. Now, soil and land, these are two different concepts, but often people get it intermixed. So, for the soil, it is a three-dimensional body. So, whenever we will think about soil, we always have to think about it as a three-dimensional body, and for the land, it is two-dimensional. So, I am not telling you this just to make up a story. These are literally lines from books and they come in the exam. That's the difference between soil and land. So, soil and land, though related, they are two different entities. One is 3D and the other is two-dimensional. Now, land is a two-dimensional entity that will represent the geographical area, and the land will comprise of everything. Whatever you see, wherever you are standing, along with the different kinds of fauna or flora growing. So, that entire part will be a part of land, and then the topmost part of the land will be soil. So, when we will be dealing with the earth spheres, you will get a more clear overview about that. And also in the upcoming classes, we will be dealing in details with how this soil has emerged and what is the basic difference between how land is formed or soil is formed. So, be with me, okay. So, land is broadly defined as the physical environment consisting of, so you see one of the major features of land is it consists of relief as well as soil, hydrology, climate and vegetation. So, soil is a part of landscape. Soil is a part of landscape, okay. Now, for the different definitions of soil, different scientists, they had their different opinions regarding soil. Okay, before that, I wanted to just mention two terms. One is landform and the other is landscape. Okay, these are very important that you know this, because these are all concepts of what a land is, and land is, I had already mentioned, it is two-dimensional. So, for a landform, the landform is any natural feature that is present on the surface of the earth, okay, and it is generated through natural processes. For instance, you can see a hill, okay, a mountain, all of these are different forms of landform that have developed through what I said, natural processes, okay. But for the landscape, it is just what you see, okay. If you are at the top of the earth and if you see a particular area in the ground, that will give you the landscape of that area. So, landscape will involve all the different landforms that you can see in a single view, okay, that you can see in a single view. So, these are the two terms I thought will be important for your future reference, the difference between landform and landscape. And the soil, actually, if I consider that this is our entire land, the soil is nothing but it is the uppermost portion of land. Soil is nothing but it is the uppermost part of land, and this is lovingly called as pedosphere. Why I said lovingly? Because I love soil science, okay. So, coming to the basic definitions of what a soil is, different scientists had opined different definitions. So, who can tell me that who is the father of soil science? This is a very basic question. Who is the father of soil science? Please answer in the chat box, who is the father of soil science. So, different scientists, I told you, had given different definitions, and these are all very important. So, yes, it is Dokuchev. Now, all of these definitions along with the names of the scientists are very important for your examination. Often matching comes, and you do not have to remember the entire definition, but you have to, yes, you have to remember the keywords, okay. So, for Raffin, he told that soil is a mixture of Earth's uppermost mantle of weathered rock and organic matter. So, wherever you will find this keyword, mixture of Earth's uppermost mantle, please make sure that it is by Raffin. Then came Hilgard. So, the keyword is more or less a loose and friable material. So, wherever you will find this keyword, it belongs to Hilgard. You can remember it like L for loose or something like that. Then here comes our father. So Dokuchev. So he said that soil is a natural body. It is a natural body that is composed of mineral and organic constituents, and it will have a definite genesis. So actually the concept of soil, it emerged from Russia. Okay. The concept of soil emerged from Russia, and Dokuchev was the first Russian scientist to define a branch of study that is entirely devoted or solely devoted to soil. Clear? After that, several studies have been made in America. And then there is another question, that who is called as the, I can write it over here, American father of soil science. American father of soil science. So after Dokuchev, there was another concept that was growing in growing in America. So who is called as the American father of soil science? If anybody knows, kindly comment in the chat box. Okay. Who? Okay. It is actually Marbut. It is actually Marbut. So Marbut is termed as the American father of soil science. So when we will read about the soil taxonomy, no, not Hilgard, it is Marbut. So when we will read about the soil taxonomy and its classification and nomenclature, then from where these names came and how the soil came, that we will read in details, don't worry. This is just basic introduction. Then came Whitney. So Whitney, his concept of soil as a nutrient bin is very famous. So you can remember that T for T, nutrient bin. Then came Joffe. Always you have to remember the year. So soil is a natural body. See, in case of Dokuchev also, they had mentioned that soil is a natural body. But here, if you remember only the natural body as the keyword, then it will be a problem. So you have to remember that it is composed of mineral and organic matter, and it has a particular genesis or origin. But for Joffe, he said that it is differentiated into horizons. So you have to remember two keywords for Joffe. One is a natural body, plus it has differentiated horizons. Okay. Then coming to Jenny. So Jenny said that soil is a naturally occurring body. So you can remember Y for Y, naturally occurring body. So all of these scientists, they have very eminent contributions. Okay. When we will go into details, we will see what these are. So here one of the contributions has been written, that he actually gave the soil forming equation, that how the soil is formed. For Dokuchev also, because he is called as the father of soil science, and he said that soil has a particular genesis, he devised a particular equation for the soil genesis, and he only said that soil, it is a function of parent material, climate and organism, P, Cl and O. And later on Jenny, he modified that and he named it, he added two more factors, one is R and the other is T, that is relief and time. We will cover all of this in details, don't worry. Then came Simonson, and he defined soil as a dynamic system governed by four basic processes. What are those? Addition, removal, transfer and transformations. We will read about this in details, but for now only remember the definitions and who gave them. Year is also very important, and Bachman and Brady, his definition is most famous nowadays, that it is a dynamic natural body. That means dynamic means it is ever changing, it is not static. Previously, people used to consider soil as an inert material that is devoid of any life, but as we studied soil, we saw that most of the microbial organisms, actually 1/4 of the entire microbial population, it lives in soil. And when you take 1 tablespoon of soil, you will find approximately 10 to the power 9 microorganisms. Okay. If you take 1 tablespoon of soil, so imagine how many microbes the soil harbors. So initially it was considered as an inert material, but slowly scientists had that thought that it is not static, because a number of physical, chemical and biological processes are always ongoing inside soil, right? So then he said that it is a dynamic natural body, and then his hypothesis became most famous. Then we will see that what is, or where does this soil actually lie? Okay, on the surface of the earth. Soil of plant. Okay, no. Actually, the definition or the name of the soil will be, I'll tell you later, it is the soul of infinite lives. This is the full form of soil. It is the soul of infinite life. So, you see that it is SOIL. So, this is the entire meaning of this word soil, and it has been originated from a Latin word. Okay. So, we will now see about the different composition of elements that are present on the earth's crust. So, this is very important. First, let us look into what the earth's crust comprises of. So, we will have actually three divisions. One is crust, then the mantle and the core. And the core can be divided as outer core and inner core. Similarly, the mantle can be divided as outer mantle, inner mantle. Crust can also be divided as outer crust and inner crust. Clear? And soil will actually lie, if this is our crust of the earth, okay, then we have the mantle, then we have the core, then soil will lie at the topmost layer of the earth's crust. So, soil is nothing but it is the topmost layer of the earth's crust. Clear? Now, let us look into the elemental composition of earth. Very, very important. So, this I had mentioned that it is the abundance of elements, that is according to weight, okay, in the crust. So, first is oxygen. So, you can remember it with a mnemonic OC alpha Ka Na Ka Mg. So, you can remember it, and the percentages are also very important. See, oxygen is around 46.6%, silicon 27.72, aluminium is 8.13 and iron is 5. So, these are most of the percentage that are asked. Oxygen, silicon and aluminium are very, very important. And if you look into the criterion, then all of these both these two, the topmost, that is oxygen and silicon, both of these are non-metals. Aluminium is the only metal present over here. Now, that is the composition of the crust, that is the entire top layer of the earth. Now, when we come to the composition of soil, okay, so what I said, that soil is the uppermost part of the crust. You should not get confused with the percentages with crust. Clear? So, for soil, you see oxygen is 45 to 50%, silicon 30 to 35, aluminium 6 to 10. So, more or less the percentages are comparable, but the basic difference will be, in case of soil, organic carbon is present, that is absent in crust. Clear? Because soil is the topmost part, and whatever flora or fauna will grow, it will be on the topmost part itself. So, when it decomposes, it will add on to the organic matter, and so the crust will not have organic fractions, but the soil will have organic carbon. So, that is one of the major differences. Coming to the mineralogy, most abundant group I said silicates and followed by oxides. So, what happens? You see that oxygen and silicon, these are the two most dominant non-metals, and they will actually form a tetrahedral structure, that is called silicate structure. It is a tetrahedron, that is silicate, and this silicate, it's the basic unit for formation of any soil mineral. Clear? It is the basic unit for formation of any soil mineral. So, because that is the most abundant group, most of the minerals that are present in the soil are silicates. We will come to that. Then, the second most dominant group is feldspar. It is 61%, followed by quartz, that is 12%. So, these are all primary minerals. What are primary, what are secondary? Just to give you a brief introduction, primary minerals will be formed as such. That is, suppose there is a rock, igneous rock, there is evaluation of magma, and then that will solidify, giving rise to rocks, and then giving rise to minerals also it can be. So that mineral will be primary mineral. There has been no alteration in chemical composition of the mineral. It has been directly derived from magma or lava. But for the secondary minerals or the silicate groups, after the weathering of primary minerals, whatever minerals will be formed, they are the secondary or silicate minerals. So this feldspar and quartz both will be primary minerals. Then we also have ferromagnesian and non-ferromagnesian that we will cover later, but mostly from the name you can identify that it will have an abundance of Fe and Mg. So we can also classify that whatever minerals have more iron and magnesium, they are ferromagnesian. Those who do not have, they are non-ferromagnesian. Then it will also comprise of several essential nutrients and trace elements and beneficial metals. So these are the essential micronutrients. The trace elements can be the heavy metals, generally lead, cadmium, chromium, arsenic and mercury. And there are several beneficial elements as well that are not directly taken up by the plants, but they help in the plant growth and development. For example, sodium, silicon, cobalt and selenium. Okay. Now another thing, it can also have this silicon and aluminium, and they are called as ballast elements. They are called ballast elements. Now why are they called ballast elements? Because although their concentration, you see, it is so high, 27.7 plus 8. So I am supposing that this is 28 plus 8. So it becomes how much? 36 percentage. So approximately 36 percentage they will comprise, but they are not taken up as any essential nutrient by the plant, right? So that's why they are called ballast elements. That means they are present in abundance, but they are not taken up by the plants. Now the next thing is what this means. What this means, that what is the difference in between the crust and soil? I had already mentioned that soil is the uppermost part of the crust and it will have organic carbon content, but the crust will not have that organic carbon. And the mineralogy will mean that most of the crust is dominated by primary minerals. See, 61 plus 12, that is approximately 73% by primary minerals, but within secondary minerals or the clay minerals, the dominant group will be silicate. Then also it will contain some nutrients or trace elements, so they will help supplying the nutrients to the plants for their growth, and that is how they will support life. Now you take a look at the chart where different percentages of elements are mentioned over here, and oxygen mostly, okay, they have written here 49.5, but it should be 46.6. So more or less the oxygen and silicon, these are the two dominant minerals, followed by aluminium and all that. So the percentages you have to memorize from this table. Very important, the percentages are. So this is the difference in between what soil and crust is. So I had already told you that the elemental signature is the dominance by OC alpha, and here OC alpha along with carbon. Very important property. The organic matter present is negligible, but here subsequent quantity will be present, substantial quantity. Then for the dominant minerals, now in case of the crust, okay, so just it's a common sense that because the crust is present below the soil, whatever processes of climate, suppose climate is there or weathering, all of that will happen where? In the uppermost part only, right? So they will directly impact the uppermost part of the crust, that is the soil. So if there is no weathering, then the primary minerals, it cannot be broken down to form secondary minerals. So that's why in the crust there will be no secondary or very few secondary minerals. Clear? But for the soil, there will be substantial quantities of secondary minerals because they are directly influenced by the processes of climate. Clear? Okay. Now, you see that I had mentioned that the definition for primary minerals, that they are formed at high temperature or pressure via magma crystallization. but secondary minerals will be formed at low temperature and pressure. We will deal with that later on. So the nutrient forms in the crust, they are generally in fixed or locked forms. Okay, most of the nutrients will be held by the crust because there is no weathering. So there is no exposure of the minerals, and in the crust also the plants are not grown, it is grown on the uppermost part. So the soil will have the minerals that are dynamic, that is soluble exchangeable pools will be there so that the plants can take that up. For the degree of variation, in case of crust, it is less variable because it is present at the bottom. It is not influenced by the weathering processes. But for the soil, it will vary excessively because it has a larger, exposure to the climatic factors. Then the primary forming processes will be igneous and metamorphic rocks because they are directly derived from the magma, and the igneous rocks can later on form the metamorphic rocks. But for the soil, weathering of the parent material will be a basic important feature. Clear? So if you have any questions so far, you are welcome in the chat box. So coming to the geochemical classification of elements. So we had read that what is and what is soil, okay, what is the composition of crust, the difference between crust and soil, and now we can proceed further. So the elements that are present on the surface of the earth, they are classified geochemically. Geochemically means that based on the different chemical processes that are followed along with the different geological processes that governs their formation. Clear? Now, the first class is lithophiles. So, litho means rock loving. Philes, whenever you see the word philes, it means loving. So, litho means rock loving, and these are preferably associated with silicates and oxides because silicates and oxides are the most dominant ones. So, lithophiles will be more dominant. So, these are the examples. Mostly you see that these are group 1 elements. Group 1 elements, lithium, sodium, potassium, rubidium, group 1 and group 2 elements. Mostly some of the group 2 like magnesium, calcium, okay, barium, strontium, etc. it might be present. So, mostly group 1 and group 2 elements, they are lithophiles. Then chalcophiles means these are ore loving. So, they are associated with sulfides, S. But one question I wanted to ask is that you know that there is a group, right, that is called chalcogens. Chalcogens. Have you heard about that? We have an entire group called chalcogens in the periodic table, and we have another group called pnictogens in the periodic table. Now, who will tell me that which group number this is? For chalcogens, what is the group number, and for pnictogens, what is the group number? So, generally, who will tell me the answer in the chat box? So, generally, for the chalcogens, these are the chalcogens, yes, oxygen, yeah, right, you are. So, chalcogens, it's not 6. I am not talking about the old periodic table. I am talking about the new periodic table that has 18 groups, okay. It's not 5 or 6, it is group 16 and group 15. I am not talking about the old periodic table with 8 groups, I am talking about the newer ones with 18 groups. So, over there, yes, it is 16 and 15, good. So, these chalcogens are oxygen, sulfur, selenium, and pnictogens are NP like that, NP, okay. So, whenever we will see the chalcophiles, they will bond with sulfides. I had written, but I hadn't mentioned oxides. Why? Because lithophiles are already forming the bonds with oxides. So, the chalcophiles, they will start forming bonds with the next element in the group, that is sulfide. Clear? So, if anybody says that which element forms group with oxides, do not get confused by the term chalcogens and take oxides, it will be sulfides, okay. So, chalcogens will form bond with sulfide. Then siderophiles are iron loving. So if you had read a bit of soil science, you will know that there are several substances called siderophores that are secreted by bacteria, and they will actually trap the iron, right? So wherever there is the word sidero, that means iron, and it is iron loving. So these are associated directly with metallic iron, and for them, for instance, iron, cobalt, nickel, rubidium, okay, all this, osmium, and the last but not the least, atmophiles that are present in the atmosphere. So they will have, these are gas loving, okay, these are gas loving, and they will be preferentially found in the atmospheric or gaseous form. So that signifies that these are very volatile elements. These are highly volatile elements, the atmophiles are, and you can know that what is the CHNO, mostly all the halogens, okay, FCl, then all the, that is the noble gases, all of them will be atmophiles. So this is the geochemical classification of elements in, is hematite or siderophile? No, see, hematite is not a siderophile, hematite is a mineral. Siderophile, siderophiles are actually not minerals, right? Siderophiles are elements, they are not minerals. Hematite has iron and oxygen, okay, and some water bound in crystalline form. So these are not minerals, okay, do not get confused. Iron is an element, oxygen is an element, but hematite is a mineral. So no, we have covered the geochemical classification of elements, not minerals. Clear? It is a mineral of iron, which is a siderophile. Iron is a siderophile, and it is a mineral of iron. So no, it is not a siderophile, but iron is one. Clear, Charan? Okay. So another thing I wanted to add is that we have, or we can classify the elements. Okay, we can classify the elements, or we can add another type of element to this group. They are called biophiles, and they will mostly be associated with biological organisms like carbon, hydrogen, oxygen, nitrogen. These can be biophiles because they are associated with biological organisms. So this is an additional classification. Coming to, you are reading soil science, right? So you have to also know a bit about the branches. So you see that these are all the study areas, and these are from where the terms came. So wherever you will see the word logi, it came from the Greek word logos, means to study, right? So you see we have pedology. Pedology, pedon means soil. Edaphology, this is a branch of soil. Edaphos also means soil, clear. But the basic difference between pedology and edaphology is that edaphology will deal with the study of soil in relation to plants. Soil in relation to the plants. Where you are reading pedology, normal geologists, okay, he can also, or he or she can also read this pedology, because it is a part of geology or geography where you are only classifying the soil, okay, as an entity. But for edaphology, that is our area of expertise. We agricultural students, we will only deal with the soil as a medium for plant growth, because our main aim is to improve the soil for agriculture, right? So edaphology is where we come. Clear? So that is the study of soil in relation to the plant growth. Geology is again entire art you are studying. Now petrology. So this R means rocks. So it is the study of rocks. Okay. Then, okay, from petrology, I found another thing that is called petrography. Petrography means it is the description of rock. So wherever you will find graphy, that means description. Okay. Yes. Then again, I found another thing with petrology, that is petrogenesis, petrogenesis or pedogenesis, suppose. So whenever you have this word genesis, whenever you have this word genesis, genesis means origin. So it will deal with the origin of either soil or that of rock. Okay, these you are studying and there you are studying the origin. Only that is the difference. Mineralogy for minerals, geography is for the description. So graphia means description. Then geomorphology for the earth and morphe means formed. Climatology, clima, that is climate. Hydrology is for water and ecology is oikos, that is home, environment, and logos means study. So these are some of the terms that are related to soil science, comes very often in the examination. This pedology, edaphology, then the description of rocks and the study of origin of rocks, very important. Okay, please keep those in mind. So now we will come to the different branches of soil science. So mostly in most of the books, if you consult in case of Schlegel also, Schlegel, you will find that there are 7 branches. Okay, but later on, due to modification, as we are integrating everything, other 7 branches also came. So the first branch is genesis and morphology, that will deal with the study or origin. Then physics, physical properties, chemistry, chemical properties, biology, biological properties. Fertility and nutrition, this is where edaphology comes in. So in relation to the plant growth, then we can have management and conservation study to prevent erosion, land degradation, all that. Then we can have soil survey and classification. So this is the entire genre of remote sensing only. But then later on, 7 more branches have been added: microbiology, biochemistry, mineralogy, hydrology, environmental soil science, pedology as a branch was also added, and soil remote sensing. So all of these are synonymous to the initial branches. I had just given you an overview. No need to memorize them in details, but just only keep it in your mind. What are the different branches of soil science? If the question comes, you will write 7. And the first 7 are those that you will mention. Clear? Now we will see earth as a whole. So composition for the crust we had completed, for the soil we had completed. Now we will come to the composition of earth as a whole. Just a second. So if you see the entire earth, then you will find that mostly it is dominated by non-metals. 2 important non-metals, oxygen and silicon, 75% or 3/4, and then only 25% by metals. Clear? Now the dominant elements that are present in earth, primary element is oxygen 46.6%, then secondary is silicon 27.72. If somebody asks what is the dominant metal, then it is aluminium. But even though aluminium is the dominant metal, it is not an important component for either the plants or for the soil structure itself. Mostly it is not there. So if somebody asks you that what is the dominant exchangeable cation that is present, your answer should be calcium. Not iron, not aluminium, not magnesium, but calcium. So even though the calcium comes after aluminium and iron, it is the most dominant exchangeable cation that is present in soil, and this was a PYQ. This was a PYQ, okay, somewhere in the year 2024 or 5, I don't remember actually, but this was a PYQ and there was controversy. The initial answer given was aluminium, clear, in the provisional answer sheet, but it is very clearly stated that the cation that dominates the exchange sites are, oh hello, okay, so thank you Tarun, okay, so then if it dominates the exchange sites, then it is calcium because it is Ca2+, clear. So I'll tell you later about how this chemistry works, but for just information, these are the 4 points, very important, please do not forget. Now coming to, you see we had only dealt with the crust and the soil. Now coming to the entire structure of the earth, we will see upper, lower, outer, inner. So these are all the different parts of core and mantle and crust. So for each one we will be covering details, but in each of these parts there are several discontinuities. Now what are discontinuities? What are discontinuities in earth? So discontinuities are whenever a wave, okay, suppose any wave, it passes through the different layers of earth, there will be a change in wave velocity. So whenever there is a change in wave velocity, at that critical junction where the change happens, we say that it's a discontinuity. So suppose a wave is moving from crust to mantle. There will be differences, elemental differences in crust and mantle. So whenever a wave will move from crust to mantle, there will be a change in its velocity. So at that case, there is a discontinuity. Okay, so two terms I just remembered. One is accretion and the other is differentiation. So you see, accretion and differentiation. So differentiation term, you know, what does it mean? Aluminium is most abundant metal in earth. Yes, aluminium is most abundant metal in earth's crust. Oxygen most abundant element. Yes, so do not forget or do not get confused in between element and metal, because element will cover everything in the periodic table, everything in the periodic table. And within the elements only are two groups, one is metals and the other is non-metals, right? So do not get confused between that. These are some basics that you should get cleared, okay, before moving further. So differentiation, from the name itself, that means there will be differences. So differentiation will happen because there are elements that are present in earth, because oxygen, silicon, aluminium, iron, all of them have different densities, right? So they will settle at their own pace, and that's what creates these three layers, that is crust, mantle and core. So if somebody asks you how is the earth formed or how are these crust, mantle and core formed, you will say the answer is differentiation, because different elements, they have different densities, specific gravities. So due to their order of settling, all these three layers have been formed. And accretion, it is actually the process of accumulation of materials. Accumulation. So these materials, from where did they come? In the earth. So first they have to be accumulated, right, to form the earth. So they were accumulated from some place and then they were differentiated. So this is how the entire earth has been formed. Yes. So these are the different discontinuities. So between the upper crust and the lower crust, we have Conrad. Lower crust and mantle, we have Mohorovičić. Lower mantle and outer core, sorry, upper mantle and lower mantle Repeti, then mantle and core Gutenberg, outer and inner core is Lehman. All the names of discontinuities are very important. I have just not kept this picture as a show or to make this slide presentable, no. All the names of discontinuities, please remember, and also where these are located. Question comes in the examination from discontinuities. Clear? So now we come to the different spheres of earth. So whatever we had read, it is a part of the solid earth. We had not considered the water, the air, okay, or the life. We had only considered the solid portion that made the earth up, and that is, we had only considered the lithosphere. Clear? So lithosphere will constitute 93.06%. So from here you can see that this is the entire lithosphere that is present over here. Okay. Then the hydrosphere 6.91 and atmosphere 0.03. So the percentages of the spheres, very important, that which is dominant and what is dominant. But these are the percentages by weight, okay, contribution by weight. But if somebody asks you, say, the contribution with respect to volume, then the hydrosphere will dominate. Hydrosphere 75% of the Earth's crust, okay, with respect to volume. Then this crust, mantle and core, I had mentioned the thicknesses as well as the densities. So you see, because the core is the innermost layer of the earth, this inner core is the innermost layer of the earth, what happens? The materials during the accretion, they were accumulated in one place, and due to the difference in the properties of the materials, some of the heavy materials, they had congregated, they had settled down due to the effect of gravity because they are heavier, and then they form the inner core. On the top, then there were some materials, and on a graded basis, from decreasing to increasing density, we have the different parts of the earth. But this inner core, it is so consolidated and it has so much pressure from all these different spheres. No, they surround the inner core. So they have so much pressure from all the different layers that the elements in the inner core actually solidified. Although the temperature is highest over there, so the minerals should have been in a liquid or a semi-solid form, the inner core is solidified due to intense pressure from the outer layers of the earth, okay. And then we have the outer core, then lower mantle, upper mantle, all of that. So this part is important, that what are the elements that are present, and these are the densities. So because the core, it is most consolidated, it will have the highest density, okay. And the thickness, it will also vary from crust, mantle and core. So now we will come into our basic portion, that is, we have studied what the crust is, we had studied what our soil is, and now we will study that these elements that are present in the earth, what do they make up? They will make up nothing but rocks and minerals. So we have not entered into soil right now. We are just on the outer surface. Only rocks and minerals that the elements will form, and these rocks and minerals, they will eventually form the soil due to weathering. So rocks and minerals will weather and then they will form soil, okay. So currently we will be dealing with the elements that make up these, and then how do they form the soil, clear? So what is a rock? It is a hard mass of mineral matter comprising of two or more rock forming minerals. So you see, the basic difference between rock and mineral is that for mineral there will be only a particular element that is present in abundance, like somebody said hematite. So in case of hematite, the dominant mineral is iron, element is iron, right? So iron will dominate the structure of hematite, and there are no other metals present except oxygen or hydrogen if water is there. So for mineral, a particular element will be present in highest fraction. So it is purer, okay, than the rocks. But a rock, it will be composed of several different minerals. So you will have a varied composition of minerals present in rock. And what is ore? Ore is something from which the mineral is derived. Suppose you have one rock, it is not essential that one rock will give you only one mineral. So one rock can give you more than one mineral. But whenever we will see that, suppose there is a rock, and in that rock there is, suppose, iron present in dominance, and that part we can extract, okay. And after extraction, again if we further extract, then we will get a mineral. So ore is nothing but these are synonymous to rocks, but that will contain an element in dominance, clear? So basically the minerals are derived from ores. So whenever there is, suppose, a steel plant going on, they will take what? Iron ore as the starting material, right? Inner core is made up of nickel, iron, which is in molten state. No, yeah, inner core will not be in molten state, inner core will be in a solid state, clear? As I mentioned. So you can say that outer core will have this semi-solid or molten fractions. Okay. So now most of the rocks that are created, they will be formed of more than one kind of mineral. Okay. So we have classified the rocks into three bases. One is geological, that is how they are made, then physical and chemical. So for the geological, we will have igneous, sedimentary and metamorphic, and this geological classification is what we will focus on. So igneous rocks, they are generally derived from molten magma. Then we have sedimentary, that will be formed from sediments due to weathering and all that. We will come into details. And metamorphic rocks, it can form from both sedimentary as well as igneous rocks. So these are the different bases. We will cover each and every rock in details, don't worry. For the physical classification, how these are present, whether they are stratified, stratification means layers, whether different layers of minerals are present in the rock, or whether it is just, in an amorphous form, or whether or not these are foliated. So foliation means bands. Okay. Then for the chemical classification, we can also divide them, whether or not silica is present, then silicaceous. Argillaceous means clay is present or not. Calcareous means calcium carbonate is present or calcium is present or not. So these are the different physical compositions that are present. Ore is a rock or soil which has high amount of valuable. No, it is not soil, it is rock. Okay. And granite basalt are examples. Okay, very good. So ore is not a soil, ore is rock. Okay, soil is something different. We'll come to that. Now I told you now that we are basically dealing with the rocks and minerals, what the elements form actually, and then we will slowly progress to soils. So we haven't come to soil yet. Okay. Okay. So basically we have classified the different rocks, and from here you can see that how one rock gets transformed to the other. So first the magma will be there, magma, and the magma on cooling it will form igneous rocks. The igneous rocks on heat and pressure it can form metamorphic. So if there is the effect of heat, then it is called thermal, and if there is the effect of pressure, then it is called dynamo or dynamo, something like that. This will be the prefix. So if there is both heat as well as pressure, then we will call it as dynamothermic. Dynamothermic. Okay, dynamothermic metamorphism. Then the metamorphic rock will be formed from igneous. Igneous will be subjected to weathering. Sediments, they will compact, forming sedimentary rocks. Again, due to heat and pressure, they can form metamorphic rock. And the metamorphic rock on the later stages, they can degrade due to weathering and again give rise to sediments. Clear? Okay. So these are the classification, and this part is called rock cycle. Now first we will come to igneous rocks. So what are igneous rocks? So these are the rocks that have been generated from the molten magma or lava. Okay, the rocks that have been generated from molten magma or lava are called igneous rock, and based on how these are formed, we can classify them as extrusive and intrusive. So first let us read the definition, that these are formed by cooling and crystallization of molten material. Okay, who can tell me the difference between magma and lava? So these are just, very silly little things, basic things that people make mistakes. So magma is actually the part, or that that heated molten material that is present inside the earth. Okay, So when the magma comes out of the earth's surface and starts flowing, then it will form lava. So you should not take these two terms synonymously. Okay, magma is present well inside the earth. It is not free flowing, but when it comes out, it will then form lava. And that magma, when it comes out, so then it can cool down, and when it comes out, then it will form one kind of igneous rock, and when it is present well within, then it will form another kind of igneous rock. So one is formed by magma, one is formed by lava. Now they are characterized by non-laminar massive structures, and they will occupy 95% of the earth's crust. So when I talk about the crust, I am talking about the entire upper portion of the crust, and the igneous rocks will make up 95%. So only 5% will be made up by sedimentary rocks. So these are the sources of parent materials for other rocks and ultimately for soil, because to form other rocks we have to first go through with igneous rocks. So how are they formed? They are formed during volcanic eruptions. This molten mass or fluid magma is forced out of the earth. So when it is forced out, there will be several volatile gases and all that are present, and that will be lost to the environment. Then the outer surface is comparatively cooler, and then they will cool down, and then they will solidify to form rocks of fine size crystal. So whenever the magma will come out and start flowing as a lava, then it will form fine sized igneous rock that we call extrusive or volcanic. Here it is written. So they have glassy structure because they have plenty of space now to crystallize. Okay. So they are called extrusive or volcanic basalt, rhyolite, trachyte. They can also have babble holes, because after solidification, suppose, or during solidification, some of the volatile materials were present and they are leaving out of the surface. Like when you bake a cake, you will see that it is porous because the carbon dioxide is evolving when you bake it. Similarly, when the volatile components will be lost, then the rock will turn into vesicular. Like pumice. Pumice is an igneous rock, but it is a lightweight igneous rock. Then when the pressure will subside within the surface of the earth, if the rocks solidify within the surface, then they will form coarse grained rocks. So coarse grained or intrusive or plutonic rocks. Okay, and these are gabbro and granite. Clear? So this is the basic difference on how it is formed or from where it is formed, either on the surface of the earth or inside the surface of the earth. So extrusive formed outside, intrusive formed inside. Okay. So originally it was magma. Original material was magma. So then the magma turned to lava and then it formed rocks. So some rocks, they can be hard and compact like granite or basalt, while others can be loose or feebly aggregated. It will depend on the type of metamorphism or process that they are undergoing, and each rock will possess certain characteristics, and from each of the characteristics we can identify that what kind of rocks are present. So first let us see the different types of igneous rocks that are present. So we can classify them on three bases based on cooling and crystallization. I had already mentioned. Then based on composition and based on silica content. Okay. So this chart is for your reference. These are some of the examples of igneous rocks that I had mentioned. You can see the picture from here. So first there will be, okay, first let's see that how these are formed. There are three stages. One is cooling and consolidation of magma. So the rocks that are formed by cooling and consolidation of molten magma. So cooling means, you know, reduction in heat or temperature. Consolidation means when the sediments will come close together, they will aggregate, that is consolidation. So these are called primary rocks, and because the magma has a very high temperature and pressure, the igneous rocks will be formed at high temperature and pressure conditions. Okay. So Then these materials, the cooled and consolidated materials, they will be transported. Okay, there will be disintegration of the larger particles, they will be transported and they will be broken down to the pre-existing rocks, and that is why some of the rocks you will see that it is feebly aggregated and some you will see that it is very hard. So for the very hard rocks like that of granite and basalt, it is not easy for the agents to transport them. Okay. So the resulting material is either compacted in situ, so it can be compacted in situ or it can be transported by different elements and compacted ex situ. So up to this process, rocks haven't been formed. Only the precursor materials of rocks are there that will be compacted. So after cooling, then aggregation will be there, sorry, accumulation, yes, aggregation will be there, then they will cement together. So first suppose you get to know somebody, okay, so that is consolidation. First you ice break, we call it ice breaking, that when you are getting acquainted with somebody, so imagine it like that. First the rocks will cool down, then they will come together, so then you make friends with that, okay, consolidation, they will come and aggregate, okay, and then they will actually get cemented together. So then your friendship grows stronger. Ma'am, when will be the answer key? Actually, though they gave the notice that in this week only the answer key was supposed to be released. Right? The NTA gave a notice, no, that in this week only the provisional answer key will be released. So just wait for a few more days, and because this week today is only the last day, that is Friday. Don't worry, they release the answer keys late at night. So they can do that even. So let's see today if it is released or not. Okay. Now, okay. So after that, your friendship grows stronger and that is cementation. So consolidation will form after this consolidation, there will be transportation and cementation of the materials. Then there can also be the alteration or pre-existing rocks. So when they are subjected to these temperature fluctuations or earth movement, then maybe these primary structures can get reconstituted to form something new. So these are the basic 3 steps for the formation of igneous rocks. Now coming to the classification, first I told you that we will divide it based on mineral and chemical composition. Ultramafic, mafic, intermediate and felsic. Mafic means it will be rich in iron and magnesium and lower proportions of silica. So iron and magnesium, it is rich. So obviously the color will be reddish brown or reddish type of, but because it has a lower proportion of silica, then it will not contain any quartz. And quartz, you know that it is formed from silica only, SiO2. Okay, so because the proportion of silica is so low, there will be no quartz. Then mafic will contain calcium feldspar. So feldspar again primary mineral. Dark color, the density will be higher. Intermediate means iron and magnesium silicate, sodium, aluminium rich minerals. So these are intermediate and they will contain lesser quantity of quartz. But for the felsic ones, they will be rich in potassium feldspar, K feldspar, again a primary mineral, or aluminium rich mica, and they will be light colored. So they have a lesser density and they do not possess that much, distinct features. So this is based on mineral and chemical composition. Coming to the basis on depth. So depth means intrusive or plutonic where these are found. Cooling rate, obviously because it will cool inside the earth, it will be slower, and the texture will be crystalline and large grained because coarse grained. Why coarse grained? Because it is cooling inside the earth, it is not getting enough time to cool down, okay, or it is the temperature is not lowering that fast. So that is why the rocks will be large grained. An example, granite, cyanide, diorite, gabbro, labradorite. Examples are very important. For each kind of rock, you will have to remember the examples. Hyperbasalt means, hyperbasalt, see, it is not present deep inside, but again it is also not on the surface. So somewhat at shallower depths, and their cooling rates is moderate because they are not well inside. Okay, they are just shallowly present. So they will form finely grained crystalline structures like dolerite. Then we have extrusive or volcanic that are present well above the surface of the earth. So their cooling movement will be rapid and they will be non-crystalline and they are fine grained like that of basalt because they have relatively got more time to cool down and they cool down even faster. Coming to the classification of rocks based on acidity. So acidic rocks will contain greater than 65% silica and silica is a material that contributes to acidity. Then subacidic rocks, similarly subbasic rocks are also there. So often scientists actually club these two together and say 55 to 65% subacidic or subbasic both can be included. And then for the basic rocks they will contain very less amount of silica. Okay. And this is a picture directly taken from Schlegel where they had mentioned the examples along with the different kinds of rocks. So this table is very important. Question comes from this table. So this is nothing that I hadn't mentioned and examples for each case. Please do read this. They often ask that trachyte and andesite, say it belongs to which group. So you cannot say neutral. You have to say whether these are subacidic or subbasic like that. Okay, so please memorize the examples. And then we have the examples of igneous rock. 2 or 3 rocks that you should know or have a basic idea about. So first one is basalt. So basalt is extrusive as we had discussed, formed outside the surface, and extrusive means it will be fine grained obviously. Then it is dark colored. Now let's see the composition. It will contain 50% feldspar and 50% ferromagnesian minerals, including pyroxene and olivine. So what these are, we will learn it in details, but for now you only have to remember 2 details. One, it is extrusive or volcanic. Second, it is fine grained. Then the coarse grained rock that has a comparable mineralogy. So basalt is actually a basic material. It is basic, and so that means it has less silica content. Just the same thing, basic, okay, less silica content, but coarse grained counterpart of basalt is called gabbro. Okay. Now pumice is again another lightweight rock. So I told you initially that it is vesicular and it is very lightweight with a lower specific gravity. So what are these lightweight and heavyweight minerals? Those that have a specific gravity of less than 2.85 gram per cc, or for specific gravity you do not have any unit, they are called lightweight. And those that are greater than 2.85, generally they are called heavyweight minerals. And pumice is light, that means it will fall below this 2.85. Then coming to granite, so it is just a coarse textured rock. So coarse textured means it will be intrusive, formed inside the earth's crust, and it will contain 60 to 70% feldspar. So just mark the difference. 60 to 70% feldspar here, here only 50. So that is why this granite, it is more acidic than that of basalt, and it will contain orthoclase that will constitute 40 to 45% and plagioclase, that is 20 to 25%. So these are nothing but feldspars. Orthoclase, plagioclase are all feldspars. So the more the feldspars, the more acidic the rock is, and for the ferromagnesian part it is only 3 to 10. Okay. So it is a fine grained rock. This is a coarse grained one, but its counterpart, that is fine grained, is rhyolite. Clear? So this was our demo class. So if you had liked it and if you want to know in details about all the different kinds of rocks, please subscribe to our master course, and we would love to hear your comments, like how you liked the first class. We would love to hear it, and best of luck to each and every one of you, and I expect you all like that. I hope to see you all in my next master class. Okay. So goodbye guys, and all the best wishes to you.